All right, hello folks. We are going to go ahead and try to move on here to the next section, 12.2. We're going to see how this goes here. This can get a little bit tricky here at times. There's a lot of terminology in this section. What we're going to be looking at in this section are angles. Okay, how to sketch them, what the different parts of an angle are. When you talk about an angle is actually made up of two rays that have a common endpoint. Okay. And so you're going to hear the phrase initial side, okay? And the initial side of your angle, for our purposes, is always going to be right here flush over top of what is the positive side of the x-axis. So all these angles that we are going to sketch, the initial side is always going to be right over top of the positive side of the x-axis. Now, how big the angle is, well, that depends on where the terminal side lands. If something's terminal, that typically means that it's going to end. And so the terminal side, of course, we know in this example here, we see that it's falling in quadrant 3, but we know that that can be in any one of the 4 quadrants. It's important that you know the names of the quadrants. They go in a little unnatural direction. They start in the upper right corner and then they move counterclockwise. These are the quadrants in the order there. But the terminal side then would be the other side of the angle. Now, you probably have only thought of angles as being positive, okay? But angles can actually be negative as well, okay? And so when we talk about a positive angle, that means we're going to start at the initial side, but we're going to move in the direction that is counterclockwise, okay? If the angle is, say, a negative angle, okay, well, then that means we're going to start at the initial side, but instead of moving counterclockwise, you're going to move in the clockwise direction. Okay, so the fact that it says negative, it's really about what direction you're moving, and you always want to keep in mind that each of the quadrants hold 90 degrees. Okay, that's going to be really helpful. We know there's 360 degrees in a full triangle. So let's look at an example here that's asking us to draw, this should be draw an angle, okay, with the given measure. It says in standard position. And so what's implied there is when we draw this, we're definitely going to be starting with that initial ray right over top of the x-axis. And I'm going to look at example B here with you to start. Okay, so you can see in example B, the angle they give us is negative 40 degrees. And so the fact that it's negative is telling us we need to move 40 degrees in the direction clockwise. Okay. Now, once again, keep in mind, there's 90 degrees in every quadrant. 45 degrees would be about halfway through that quadrant. So if we're looking at moving 40 degrees, it just might be a little bit shy of the halfway mark. I'm just going to roughly put it right there. And then right inside here, you can label negative 40 degrees. Okay, that would be drawing a negative 40 degree angle. Okay. You can see the example that I skipped over here. Example A asked us to sketch a 215-degree angle, and because that was positive, we again started right here on the x-axis, but we're moving in the counterclockwise direction. And you just want to keep in mind that there's 90 degrees here, then we would have moved 180 there, and then of course we would need to go an additional, if we're going 215 and we already traveled 180, that means that we need to go like an extra 35 degrees down there. That's how we were able to kind of figure out about where that would land. Okay, so you really got to use that there's 90 degrees in each quadrant to try to get these to land in a relatively believable spot there. Okay, so let's look at example D. This is another negative angle. Okay, we are starting with the initial side right here on the x-axis. We're going to go in the clockwise direction. Okay, it's going to be negative 105. So I know once I get right here to this y-axis, I've gone 90. So, on my calculator, I might take 105 and subtract 90. And that tells me I have a remaining 15 degrees that I need to go into this quadrant 3. So maybe right there would be a nice way to sketch it. Okay, and when you sketch these, please put an arc right on the inside and just label right inside there the angle measurement. Okay, very important that you label inside there. Okay, all right, so that's how you sketch angles. Positive, negative, you just got to go the right direction. Here's another term. This term is called coterminal angles. And what coterminal angles are those are basically two or more angles that when you graph them in standard position, they actually end up landing in the exact same spot. And so in essence, you're either just going full circle, 360 degrees, either adding it or subtracting it, and you're in the exact same position. Okay, I'll give you an example. Let's say that we were to go in the positive direction, a 270-degree angle. So I would go 90, 90, 90. So I would draw a 270-degree angle looking like that, okay? Or if I drew a negative 90-degree angle, again, I would start here, but now I'm going clockwise. A negative 90-degree angle would land right there. Now I'd label that right in here, but if you look at where the rays start and stop, they're the exact same position. And so these two angles are considered to be coterminal angles. Okay, this example too is just wanting you to sketch basically a 540-degree angle. Okay, we know we're going to start here. It's positive 540, so we're going to go this direction. Okay, so we're going to go all the way around 360 degrees. Okay, so I'm going to subtract 360 off of 540, and that tells me I still have to travel an extra 180 degrees. So I'm going to go 90, another 90. So technically, a 540-degree angle would land right over here. We go full circle and then another 180. Okay. Okay. So what we're going to be practicing here on example 3 is they're going to give us one angle, okay, like a 130-degree angle. They're not asking us to sketch this, but they are asking us to come up with a coterminal angle, one that would be positive to 130 degrees and one that's negative. Okay. Now, every time you go 360 degrees, you're landing in the exact same spot. And you can keep adding 360 infinitely or subtracting 360. So when we talk about coterminal angles, there are an infinite number of coterminal angles for any given angle. So for example, all we're going to do to get one other positive coterminal angle to 360, or sorry, to 130 degrees is to just add 360 degrees to it, okay? If you add 360 degrees to 130 degrees, that gets you at 490 degrees. There's an example of a positive coterminal angle to 130. Okay, we're also asked to list a negative coterminal angle, and so what I'm going to do to 130 is I'm going to subtract 360 off of 130, and that gives me negative 230. Okay, so here I've listed one positive and one negative coterminal angle to 130. If you were to graph 130, someone else were to sketch a 490-degree angle and someone else a negative 230-degree angle, they would all land in the exact same spot. Okay, so the idea is you just want to add 360, subtract 360. It does ask you for one positive and one negative. So in this next example, the angle they give you is really, really negative. It's negative 600 degrees. And so when you add 360 to that, the answer is not going to be positive because negative 600 was so negative that we get negative 240. So I'm going to go ahead and use that as a negative coterminal angle. But then to get a positive coterminal angle, I'm going to have to add 360 again. It's like I'm going to add it twice, okay? I'm going to have to add that like 2 times or until it spills over into a positive angle. Okay, here are 2 possibilities. There are like lots of possible correct answers for these guys. You just want to keep adding 360 or keep subtracting 360 until you get one answer that's positive and one answer that's negative. Okay, so these are not the only answers to these, but this one was already done for us, and so was the other one there. Okay, now we're going to take a look at what radian measures are. I know that I've mentioned to you that when you use sine, cosine, and tangent, you need to make sure your calculator has been in degree mode, but there is another mode, and that's called radians. And so technically, angles can be measured in one of those 2 ways. Now, here's what a radian measure is, and this can get a little confusing. A radian measure is actually measuring how much of your circle is being intercepted by the angle. Okay, specifically 1 radian, that angle, 1 radian measure is the amount of your angle that is capturing what would be the arc length, that if you stretched out the arc length right here, if you uncurled that curved part, so let's say you straightened that out and then you measured that distance would be equivalent to the radius of your circle, okay? So let's try to put this in some simple terms here. Okay, we know that if you're talking about degrees, there are 360 degrees in a circle. Okay, if we're trying to figure out how many radians are there in a circle, then what we're really trying to figure out is how many times around the outside edge of the circle could you wrap the radius of the circle. Okay, now I want you to think about circumference for a moment. Circumference is the formula for what the arc length is all the way around a circle. You may have seen that as the formula pi d, but I'm going to write that as 2 pi r. That's another way of writing the circumference formula. Okay, so if we're trying to figure out, if we go all the way around this circle, how many radii could you wrap around the outside of any circle? Well, our answer is right here in the circumference formula. If you were to look at this as a decimal, 2 pi is 6.28, and then r is radius. So what this means is technically you could wrap about, there's 3, here's 4, there's 5, 6, and then a little bit extra, like that would be 0.28 of a radius. You could wrap a full 6 radii and then a little more than a fourth of a radius all the way around any circle, okay? Any circle, that's what you could wrap around, okay? So what we want to try to get here is that if you go 1 revolution, that's all the way around the circle, 1 revolution is 2 pi radians. Okay, 2 pi radians is equal to 360 degrees. Okay, these two things, this is how you convert back and forth between radians and degrees. Okay, if 2 pi is all the way around the circle, then 1 pi would be halfway around the circle, which would be 180 degrees. Okay, and so we're going to talk real quickly here about how to convert from degrees into radians and from radians into degrees. And I think you'll notice here that what we typically end up using is we end up using this relationship here. Okay, so what you want to do is if the problem starts out in degrees and you're converting to radians, you need to multiply by pi over 180. And if it starts out in radians and you're asked to convert to degrees, then you need to multiply by 180 over pi. Let me show you this in a couple examples. I have a few of these worked out already for you, but here's how this is going to look. Here we're starting out with negative 30 degrees, okay? And we want to convert this into radians. So I'm going to make this look like a fraction, okay? I see up here that according to the formula, if I am in degrees and I want to go to radians, I should be multiplying by pi over 180, okay? Now what you're going to do on your calculator is you should type into your calculator negative 30 divided by 180. Do not enter the pi symbol at all on your calculator. You're going to leave the pi symbol in your answer for radians, okay? So you would just type negative 30 divided by 180, switch that back into a fraction, you're going to see negative 1/6, but then attach that pi symbol back onto the answer, and we say that it would be negative pi over 6 radians, okay? Let's look at this one here. We're going to convert 120 degrees into radians. So we're going to be multiplying that by pi over 180. Okay, again, on the calculator, you would do 120 divided by 180, switch that back into a fraction, gives you 2/3, and then just reattach that pi symbol back onto the answer. Okay, if we were going to go the other direction here, we would start out with, if you see a pi symbol, the assumption there that's in radians, well then here we're going to go from radians to degrees, so you're going to multiply by 180 over pi. Now what happens here is the pi symbols cancel, and then you can just type 5 times 180 divided by 2, that's 450 degrees. Okay, one more example here, pi symbols cancel, you're typing in negative 3 times 180 divided by 8, this converts to negative 67.5 degrees. Okay, your homework assignment is to only do the odd problems on this worksheet. Please message me with questions. I know some of this is a little bit tricky. I'm willing to help any of you that have questions. Thanks so much.